Aloha, this is section 2.7, which is probability of compound events. So instead of just finding the probability of a single event, compound events means more than one. There are two types of events, independent events and dependent events. Okay, so independent is when you have events that the previous outcome doesn't affect the next outcome. So for example, if you're flipping a coin 10 times, if you get 9 heads in a row, that 10th time, all those 9 prior ones doesn't affect the 10th flip. It's still 1/2 of a chance of getting it. Okay, or even rolling a dice. After rolling a dice, when you roll it the second time, whatever you get on the first outcome doesn't affect the second outcome because they're independent. Okay, the main difference between independent and dependent. The independent event, you can select something with replacing it in, and I'll show you an example of that. And a dependent event, you select something without replacing. And again, I'll show you what those two means. So again, dependent, whatever happens prior in the first event will affect the probability of the second event. So the second event is dependent on the first event. Whereas in independent, it doesn't matter. They're all independent events. Okay, so I'll show you some examples. So here's independent events. The probability of A, whatever A event is happening, and B happening is just probability of A times the probability of B. So you're just multiplying the two probabilities. So for example, the probability of flipping a coin 2 times and getting a head and a head, so 2 heads, is 1/2 times 1/2. So you just multiply the probability of getting this, which is 1/2, times the probability of getting the second head, which is 1/2. And your answer is 1/4. Okay. If you rolled a 6-sided dice, the probability of getting a 2 and a 6. So this would be 1 out of 6 times, and the probability of getting a 6 would be 1 out of 6. Okay, so it's just 1/6 times 1/6. Which is equal to 1 out of 36. Okay? So the probability of rolling a 2 and the probability of rolling a 6 is 1 out of 36. Okay, if probability of rolling a 1 and then an even number, so the probability of getting a 1 is 1 out of 6 times probability of getting an even number is actually 3 out of 6, which you can simplify to 1/2. So when you multiply those across, 1/6 times 1/2 is equal to 1/12. So you can see it's a higher probability of getting this event than this because there's more chances because there's a 2, a 4, and a 6 here versus just a 6 there. Okay, here's another one. If you had a probability of getting a head, a tail, and then a head, so you're flipping the coin 3 times, it's just multiplying it. 1/2 times the tail would be 1/2. And this head would be 1/2. So it'd be 1/8. Okay, so you're just multiplying all 3 probabilities. And if there's more probabilities, again, you just multiply them all the time. Okay, so here's the difference between dependent and independent. So again, with replacement is independent. And without replacement is dependent. Okay, so if I have a bag of 8 marbles here, there's 1 blue one, 4 greens, and 3 reds. Okay, and I tried to color code it for you. So the probability of pulling a green marble out first, and then a red, and I'll show you how to do it with replacement and then without. So with replacement, if you pull a green marble out first, the probability of that green marble is 4 out of 8, which is 1/2. Okay, and the probability of getting, and then to replace it means you put it back in. Now the probability of getting a red is 3 out of 8. So you're just multiplying times 3 out of 8. And when you multiply that, you get 3 out of 16. Okay, but when you do it without replacing, The key part is you have to assume you're getting this first one. So the probability of getting a green one is 4 out of 8, which is still 1/2. So you can see that's the same here and here. But you got to assume you took one of the green ones out. Okay? And so now the probability of the red, because you didn't replace it, is now 3 out of 7 instead of 3 out of 8. So when you multiply that out, you get 3 out of 14, or 3/14. So you can see the difference between this with replacing and without replacing. Okay. So let's put the green marble back in. And now let's do this one. So probability of a green and then a blue with replacing. So again, the green is still 1/2, 4 out of 8. And if you put it back in, the probability of the blue is 1 out of 8. And you just multiply it and you get 1 out of 16. Okay. When you do it here without replacing, again, 4 out of 8 is 1/2 for the green. And the blue, if you take the green out again, so we're going to not replace it, and we got to assume we took the green, the blue is now 1 out of 7. And so when I do that, I get 1 out of 14. Okay. If you want to pause now and see if you can do these 3, go ahead and see if you can do some of those on your own and come back, and then I'll solve it out for you. Okay, for this one, probability of the blue, oh, sorry, I forgot to put the green one back in. Let's put the green back in. Probability of blue is 1 out of 8. And the probability of a red, if you put the blue back in, is 3 out of 8. So when you multiply that out, it's 3 out of 64. Okay. And it should make sense that this is harder to get, 3 out of 64 to 3 out of 16, because this one you got 4 chances of getting a green, whereas this one you only got 1 chance of getting a blue. Okay, so going to this one now, the probability of getting a blue is still 1 out of 8. But now for the red, if we eliminate the blue, the red is now 3 out of 7. When you multiply that across, you get 3 out of 56. Okay, so you can see the difference between the two. I'm going to put the blue one back in. So now here's where it gets a little tricky, and if you try these on your own, that's great. A red and then the red. If you replaced the red, so the first one would be 3 out of 8. And if you put it back in, it's still 3 out of 8 because you put it back in. So when you multiply that out, you get 9 over 64. Okay. Whereas over here, without replacing, if you take the first red out, you get 3 out of 8 for that probability. But if you take one out and you don't replace it, now there's only 2 out of 7. Because there's only 2 left out of the 7. And so when you multiply that, you get 6 out of 56. Simplify that down, 3 out of 28. Okay. And you can see it's going to be much harder to do down because the red is now gone. Okay. Let's put it back in for the blue and the blue. Over here, the blue, if you blue and blue with replacing, 1 out of 8 for the first blue. Put it back in, the second blue is still 1 out of 8. So you get 1 out of 64. Okay. Over here, if you take the blue out, you got 1 out of 8 chance to do it. But if you take it out on the second one to get a second blue, there is none. So it's times 0. And so there is 0 chance of getting 2 blues, which makes sense because you cannot grab 2 blues out of this if there's only 1 in there. Okay? I hope that helps. I hope you have a wonderful day. God bless you.